Wonderful students. So I guess your paper went really well. So I'm requesting all of you to share your experience in the comment section so that I can understand how much you did in your pre-board examination. That was your first day in your pre-board examination. So please let me know how was your paper. I can see Maya. Okay, so you got really benefited out of the MCQ PDF. It's really good. Okay. Okay, very good. MCQ was almost same. Very good. Very good. Silent boy. Okay. It's really nice to see you people that your exam was really went and you got some common question out there, and the video, all the question that we solved, and overall my effort was really beneficial for you. Okay, Muhammad super 68. Okay, Maya 60 plus Pakka. Very good, very good. It's really nice, that so satisfactory to start a new year for you and me as well as a teacher, that you are getting this type of common questions and all from the benefits. It's really great. So yeah, without further delay, let's start with the revision of the MCQ. Check once if you did it correctly, and later on we will also proceed with the numerical problems. We will check once if the process or the answer that you got is correct or not. Yeah, let's start without further delay. Okay, so before paper discussion, just let me tell you, my dear, your pre-board examination is going on. I know that, but you people are studying for the KCET as well. So our Deeksha Karnataka channel has launched ABHYAS KCET test series. That was the most awaited test series from our channel, and for you people as well. So if you want to really get top 1000 rank in KCET, please enroll yourself today, and without further delay, please attempt the 35 mock tests out there so that you can understand your preparation level. So yes, without further delay, let's get started. So that was your first MCQ. Can you please tell me what was the answer that you wrote over here, so that I can understand? So the first question, you can see, among the following organic compounds, the compound which contains chiral carbon. So if you just see option C, so that is 2-chlorobutane. So this is my butane structure. So in the 2 position, let's write one chlorine. So here I am having hydrogen. So you can just look at this C. This particular carbon is chiral because I am having one methyl, one ethyl, one chlorine, one hydrogen. So many of you are giving option C, 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 C. Very good, very good. Yes, option C is the correct one. Let's proceed further. Cumin hydroperoxide on hydrolysis of dilute acid. Tell me, what you got? So for this case, this particular question, cumin to phenol synthesis, last day I told you MCQ type of question comes out of it. Okay, Harshvardhan, I can see your comment. Hi ma'am, paper was very, paper was very something because of you. Okay, thank you so much. Thank you my dear. So here you can see I am getting the answer phenol and acetone. Please let me know how many of you gave the correct answer. Okay, very good. Let's proceed. Here you can see the color of para-hydroxyazobenzene. So this is basically the diazotization, right? So this is basically orange in color. Keep giving the answer so that I can understand that you people did really well. Okay, now here you can see the order of reactivity of HX to break down the COC bond. So that's basically is going to be HI, then HBr, then HCl. So for this particular question, your answer is going to be option C, right? Next, let's proceed further. Here you can see the common name of ethane dioic acid. So ethane dioic acid, that was also a common question directly taken from the model paper itself, right? So this particular thing is oxalic acid. Let's proceed. Here you can see the graph, the plot that represent the zero order reaction. Give the answer. So here the answer is going to be option A. If you just see the zero order reaction, then you will understand that particular case, the equation that comes, that corresponds to the this type of graph. Let's proceed further. Here you can see the stable oxidation states shown by the element at atomic number 21. So atomic number 21 is for the scandium, and most stable oxidation state is +3. Let's proceed. Yeah, my dear, I can see home cooking journal. Ma'am, for tomorrow's physics exam, will the question come from the model papers SM? Yes, definitely. So let me just tell you, my dear, after these paper analysis class, you will get the live session. That is also a short live session on the physics sir with Somik sir from 4 o'clock. Please don't forget to join over there. Okay, let's proceed. The chemical formula of Hindenburg reagent, so that is basically C6H5SO2Cl. So that's going to be the correct answer. That also we discussed last day. Here you can see Tollens reagent, that also we discussed. That is the silver nitrate, freshly prepared ammoniacal silver nitrate solution. Let's proceed. Here you can see the actinoid which shows maximum oxidation state, that is the neptunium, NP. Let's proceed. Here you can see the function of enzymes in the living system is to catalyze the biochemical reaction. Option A is going to be the correct one. Let's proceed further. Here you can see the ligand which forms the stable coordination complexes. Repeated question, right? In the model paper, the same question we did. So that basically is going to be carboxylate because it's a bidentate ligand, right? Here, let's proceed. Statement 1. If on mixing the two liquids, if the solution becomes hot, it implies, it shows negative deviation from the Raoult's law. Definitely yes, because we know enthalpy of mixing value becomes less than 0, right? Less than 0 means it's an exothermic process, right? And thus it is a negative deviation of Raoult's law. That is a condition, right? Now here you can see solution which show negative deviation are accompanied by decrease in volume. Yes, delta V mix also is negative. So both the statements are correct. Option B is going to be the correct one. Let's proceed further. Okay, here you can see, I told you last day so many times that units for these particular terminologies are very important. So for this particular case, you can see E cell stands for V, means it's D, volt, right? Lambda M is basically this, Siemens centimeter square mole inverse. So that's gonna be C. For kappa, it's going to be A. For G star, it's going to be B. So you can see your answer is going to be B. I guess it's clear. Let's proceed further here. Okay, so a student took 2 glasses of pure water. Repeated question from the model paper, right? We did it earlier. So a student took 2 glasses of pure water from a water filter. He cools glass A in a fridge and warms other glass B on a stove. On comparing the solubility of oxygen in H2O in glass A and glass B, so as glass A was freezed, so temperature was low, right? So low temperature means more solubility. So glass A is having more oxygen, B is having less oxygen, right? So option B is going to be the correct one. Let's proceed. Here you can see on oxidation state of, here the fill in the blanks type of question it came. You can see oxidation state of nickel in NiCO4. Okay, so for this case CO is a neutral ligand. So here you can see nickel is going to be 0 itself, right? So nucleic acids are the long chain polymers of nucleotides. Okay, now CH3OH is also known as wood spirit. Okay, so next question you can see the unreactive, non-toxic and easily liquefiable halogen containing organic gas. This is freons. Next you can see the semi-permeable membrane generally used in reverse osmosis is made up of cellulose acetate. Okay, so okay, I'm getting some doubt. Yes, which doubt? Paper was hard. Okay, why beta? Why you feel the paper was hard? According to me, it was neither too easy not too difficult, because so many questions are repeated. If you just go through my videos and the model paper, it is a quite similar, same value. Numerical, I also got the same thing that I last day we did in the live session. Same numerical actually came over there. Same question, like the I can just give now one example, like that acetone, right? Cumin to phenol synthesis. The same question it came, right? So that's why you can't say that paper is too much difficult. So definitely, if you study a little bit a selective level question, then you can definitely get a 65 plus. Okay, so can you please tell me once again in which question you are having doubt? Can you please repeat that? Lakshmik, can you please tell me which question? Graph question. Okay, graph question. Let's go back to the graph question. Okay, for this question, I guess, so you are asking why not option B, right? You're asking is why not option B. See beta, the thing is, whenever option B, if you just look at option B, it shows that R will not tends to 0. Okay, but in case of zero order reaction, we know it undergoes completion, but first order reaction it doesn't undergo completion, right? As R will be 0, there is a possibility for a zero order reaction for a completion, so you can mark option A. Both the case the equation will be same, but you have to know in which case the reaction will be completed. We know that for the first order reaction, the reaction will take infinite time to get completed, right? But for the zero order reaction, it's not something like that, right? It will get completed, so just finish it like that. Is it okay? Lakshmik, please let me know if you understood this. These particular graph and this particular graph, the nature is quite similar, the slope, everything is similar, but the thing is it explains the completion of the reaction. Doubt in 15. Okay, let's proceed. 15. Okay, so for this question, it is actually taken from the model paper itself. So basically what happens, if you increase the temperature, solubility decreases. If you increase the temperature, solubility decreases. So if you increase the temperature in B you are heating on stove, right? The solubility of oxygen, what? It will be less over there in the B, right? And A, what you are doing? A, you are cooling, right? So temperature is decreasing, hence solubility will increase. So in A there are more oxygen, B there are less oxygen. I guess it's clear. Okay, A contents. Okay, I didn't see the question. Fine. A contents glass A and B. He states that glass A contain more oxygen than B. Okay, now it's okay. Okay, let's proceed. I was thinking with respect to B. I didn't see the last line. Okay, let's proceed. I guess it's clear now. The doubt is clear now, I guess. Okay, let's proceed. Question 12. Question 12 is B. It's B only, beta. Let's proceed. Evaporation took place in 15. Evaporation, beta, it's all about the temperature and solubility relation. Okay, so like in which point of view you are asking for the evaporation? It is getting oxygen, how much it is getting dissolved in the water. That's it. Okay, let's proceed. Okay, so I guess it's clear. Let's proceed for the numerical problems. These are the direct numerical problem that we did in the last video session as well. So here you can see, let's just calculate. You can see the value over there. I'm just doing it for you. So it is basically TB minus TB0, right? So for this case, let's put the value 354.11 minus 353.23. So if you just subtract them, it will get 0.88 Kelvin over there. Okay, someone is saying it is 57.5. You are absolutely correct, my dear. Let me just show you the process. So now we know that delta TB equals to KB into M. So from there I can calculate the M value. So M value is going to be something like 0.88 divided by 2.53, right? 2.53 mole inverse. Okay, so if you calculate this thing, your answer will be 0.3478 mole per kg. Okay, next step, from the molarity we can find out the moles. From the molarity we know equals to moles of the solute divided by mass of solvent, moles of solute. See, I am doing it part by part so that the the calculation becomes easier. You can write the direct formula and you can calculate it in a single chance. Okay, so anything will come, anything you do, it's okay, fine. So moles, it is something like 0.3478 into 0. See, here they have given something 90 gram, so we can take it in kg, 0.090 kg, and here I am having mole per kg, right? So if you calculate this, your answer will come as 0.0313 mole. Okay, from there if I proceed further, if I want to find out the molecular weight, so molecular weight is going to be mass divided by number of moles. So mass is given how much? 1.80. So 1.80 gram, and here I am getting 0.0313 mole, right? So from here I will get 57.5 gram per mole. Okay, so that's the way you can actually solve it. Direct formula is nothing, just in the place of molality, here itself I'm breaking down molality, right? In the place of molality itself you can write the formula of molality. So what is molality? This same thing, moles of the solute divided by mass of the solvent. Okay, that you can write. If you are not writing, if you are not putting the value in kg, then multiply with 1000. That's it. Okay, so that is a direct formula that also you can implement over there and you can get the value out of it as well. Okay, so let's proceed for the next question. Here you can see this question is actually based on the Arrhenius equation. Last video also I told you from the Arrhenius equation the thing is going to come. I am just showing you how to put the value, what is given, and directly I am telling you the answer. That's it. Okay, so here you can see, so I am having T1, I am having T2, I am having K1, I am having K2. So T1, T2 is given as 500 Kelvin and here it is given as 700 Kelvin. K1 is given as 0.02 second inverse and K2 is given as 0.08 second inverse. Fine. So now let's just put it into here. Arrhenius equation, K2 by K1 equals to EA by 2.303 R into 1 by T1 minus 1 by T2. So here if I put the value and if I calculate, so let me just put it over here. K2 is something like 0.08 divided by 0.02. Here I have to find out EA divided by 2.303 into 8.314 into 1 by 500 minus 1 by 700. That's it. So if you just calculate the value of EA out of this, you will get something 2011.4 joule per mole. Okay. Okay, so if you just take it in kilojoule, so 20.1 kilojoule per mole. That's going to be your answer. Okay, I can see Shreya. Okay, very good. Okay, so I guess it's clear to you now. I'm not going to the thorough calculation. I guess you could do it, because here a very simple value of log 2 will come, that we know already 0.3. Okay, so I guess it's okay. Yeah, it's definitely correct. It's definitely correct. If you just proceed up to joule, if you write, that's also okay. Okay, but make sure that you are writing the unit. Okay, unit is very important, joule per mole. Okay, let's proceed further. Here you can see, calculate the electromotive force of the cell, assume the cell reaction at 25 degrees Celsius. Fine. So this is basically the direct implementation of the Nernst equation, right? So let's proceed. Okay, so here you can see E cell equals to E0 cell minus 0.059 divided by N into log, so product by reactant directly we can implement Cu2 plus divided by Ag plus whole square, right? So now just put the value over there. Okay, Mayuri Sai, are you getting like doubt to calculate log 4? So let me just show you once. Here you will get log 4, right? So log 4 I can write it as log 2 squared, so hence 2 into log 2. So log 2 value is 0.3, you can put it over there. Like that you can simply calculate, okay? So that's gonna be the correct answer, okay? That's for sure. Okay, 20.1 kilojoule per mole. Next, or else don't worry, if you are just doing any mistake in the last step, no, you will get proper marks step wise. Okay, make sure you are writing the formula and you are just substituting the value properly, then you will get 2 marks out of it. For proper calculation, 1 more marks, like that. Okay, so now here you can see, we will proceed with this type of this problem. Here also we can just simply put the value. Okay, so 2.97. okay, iron is saying something, iron Bepari, T2 minus T1 by T1 into T2. Yes, that's only, no, here the same thing. If you just simplify this thing, no, the same thing will come, T1 into T2, so T2 minus T1, right? Same thing it will come only if you just calculate. Okay, let's proceed. For this question, 2.97, so if you just here you can see N value will come as 2 electron is getting transferred. So here if you do 0.0296, okay, log, put the concentration value for the Cu2 plus, it is 0.250 divided by, here it is, okay, here it is 1 into 10 power minus 3 whole square. Okay, so now if you just calculate the entire thing, I am not going detail to it. Okay, I am not going detail to this calculation, so your answer will come almost like 2.98. Okay, so whoever is telling that answer, it came 2.9, very good for them. I can see Shonak, very good my dear. Let's proceed further. Here you can see, this is a question that is from the model paper itself. We solved it in our model paper session. Okay, so here you can see this type of question, like any kind of radioactivity decay, I told you that will also follow the first order kinetics, right? So from here, at first let me just calculate the decay constant value. So T half is given 5730 years. From here I can get T half equals to 0.693 divided by lambda. Lambda is the decay constant here. So 0.693 divided by T half is 5730. Okay, ER inverse. Okay, so let me just keep it like that. I will calculate it later. So directly you can implement it in the first order rate equation, that is 2.303 divided by lambda into log N0 by NT. By the question they are saying is NT is 3/10th time of N0. So from here I am getting N0 by NT equals to 10 by 3. So from here if you just put the value over there, 2.303, I am putting the lambda value from here, into 5730 divided by 0.693 into log 10 by 3. I am not going for the further calculation. So if you calculate the entire thing, your answer will come as something 9953 years. This thing. Okay, I guess this is clear to you. Let's proceed for the next question. Here you can see this particular question is also from the model paper. You may feel that it's a little hard, but actually not. It's also it's a model paper question. Okay, so just let's give it a try. You can see for the H plus value of lambda 0 and HCO minus value is also given. So from here we can calculate the lambda M0 for the methanoic acid. That is lambda 0 of H plus lambda 0 of HCOO minus, right? So put the value over there, 349.6 plus 54.6. So if you calculate, your value will come around, something 404.2 Simon centimeter square mole inverse. Okay, abhi now what you have to do, you have to find out alpha. Alpha is basically lambda divided by lambda M0. Okay, so that is basically 46.1 Simon centimeter square mole inverse divided by 404.2 Simon centimeter square mole inverse. From here I am getting the value. If you calculate 0.11405. Fine, now I got the alpha value. Now I will put it into the equation, that is Ka equals to C alpha square. Ka equals to C alpha square divided by 1 minus alpha. If you put the value here, C is given over there, 0.025, right? 0.025 into alpha, you can see, you can put the value 0.11405 whole square divided by 1 minus 0.11405. So this is the entire thing. If you calculate further, your answer will be 3.6 into 10 power minus 4 mole per liter. That is your correct answer. Okay, I can see PPL are given. Shaunak, very good. Make sure that you are writing the unit properly. Anything better, Shaunak, 2.9, 2.8, 0.1 difference will not, it will really not matter in your marks. Okay, so 0.1 difference they will consider. Okay, no need to be upset about it. Okay, it's fine. If you're getting 2.8, 2.9, everything is fine. Okay, let's proceed further. Okay, so you did up to alpha. You will get 2 marks if you did it correctly. Okay, if you did it correctly with units and all, then here unit is mandatory. Okay, so if you did it correctly, then you will get 2 marks. Okay, so let's proceed for the next one. Okay, so this is a question, it's a very super easy question actually. Whoever has attempted this question, they win. Okay, so basically here you can see, we should stop at finding alpha. Dissociation constant they are asking, my dear. Okay, calculate dissociation constant. Dissociation constant is Ka, not alpha. Alpha is degree of dissociation. Can you please say how did you arrive to this unit? Okay, so basically beta, here if you just look at this particular portion, that is a normal unit of molar conductivity. Okay, Simon centimeter square mole inverse. Whenever you are calculating alpha, they will get cancelled out. right? And here whenever you are putting it into the dissociation constant, only the unit of C will come. What is the unit of C? Mole per liter, right? So Anushri, I guess you understood this. Only the unit of C, see, it is only mole per liter, no? I guess it's clear to you. Let's proceed further with the last problem. So here you can see we can apply this particular formula. P of solvent is basically mole fraction of solvent into P naught of solvent, right? Here I can apply this particular formula. So this particular is the vapor pressure. So that is basically X. X I have to calculate. So X, for this X value, mole fraction value is coming 0.4 and P0 is coming 1.013. 1.013, here you can see if you calculate, your answer will come 0.4052 bar. Okay, this is the answer. So I guess you understood these things, whatever by which method you actually should follow this, and you got the correct answer of your questions as well. I guess that particular session was beneficial for you, so please don't forget to join your next physics session, because your next paper is also knocking the door. So yes, stay tuned and keep preparing for yourself for the maximum marks. Thank you so much.